Hello ladies and gentlemen, welcome to the third problem set. So it says here, write a program which takes text from the user and then print the occurrences of all characters in that text. Note that capital letter C and C should be considered C. In other words, the text is case insensitive. So it's case insensitive. So here, the sample input, we have C language is a very powerful language that allows programmers to fully control their computers, which is true, by the way. And here we have a sample output. So we have space. So we have 14 spaces in that text there, that small paragraph. We have 8 times the letter A, and then we have 3 times the letter C, and then we have 7 times the letter E, and we have 2 times the letter F, and so on and so forth. So you have to take text from the user and then print for every character in that text its occurrence. How many do we have from that character? Okay? So let's do that. Now, the first solution that comes to someone's mind is to always iterate through all the characters. So it's like you have to say, for every character here, search for how many occurrences do we have in that character. Okay, and basically print that number out. So for example, let's start with space. So here we have, or let's start with C, the first character. So here we have C. So we start counting how many C's do we have. So that's 1, that's, 2, and we have there 3. So we have 3 C's here. So we print C3, and then we move to the next character, which is space here. So space, and then we start counting. So that's 1, 2, 3, 4, 5, 6, 7, 8, and so on until I'm going to get 14. So I print space and then 14. And then A, I go to A, and then I start counting. So we have A there, A there, A there, and a lot of A's here, and that will print 8. Okay, so that's an algorithm that you can follow in order to solve this problem. So let's do that. Okay, so the first thing, I'm gonna copy paste that text there. Let's copy paste that text there. And I'm going to create a char array, so that's a string. So I'm going to call that text, and then I'm going to give it that text there. And I'm going to change that capital letter C to small letter c for now, and I'm going to get it back later. So, let's do it in code, okay? So the first thing we have to do is to iterate through all the string, and whenever we find a capital letter C, we're going to make it small letter c. So there we have an iterator I, and then for I starts at 0. Let's get the length of the text. So we have len equal str len there of the text. So now we know the length of the text. Now let's iterate through all that text. So for I less than len I plus plus. That will allow us to access every character of that string. Now for every character, what we're going to have to do is to check if it is capital letter, then we're going to make it small letter. Okay? So basically there's a function that can do that for us, or we can do that manually. So I'm going to include the C type.h, which will allow us to access a function called toLower. So that toLower will get the character. So, first of all, let's extract the character from the string. So char C equals text of I. Okay? So we said that we're gonna loop through the entire text, and then for every character we're currently on, we're gonna copy that character into a newly created variable called C. Now that C will be converted to its lowercase representation. So there's a function for that, which is called toLower, which exists at the C type header, which will take a character and then try to convert it into lowercase. So C takes toLower of C. Okay, now C is lowercase, so we get C back to textify. Okay, so we extract a character, we make it lowercase, and then we put it back. Alright, now that's the first task. The second task is basically to iterate through all the characters once again, and then for every character iterate another time to calculate how many times do we have that character exist in our text. So I'm going to try to break this down as much as I can. So I'm going to use functions. So let's create a function which, given a character and a string, it'll compute how many occurrences of that character in that string. So the function I'm going to call this function compute. So it's a function that integer, which is the number of occurrences. So compute oc, which stands for compute occurrences. And I'm going to give it the character, the target character, and then I'm going to give it a string. So that's str string. Now, in order to compute the number of characters, well, let's first of all get the length of the string and put it inside the len variable. And then we're going to have to iterate through the entire string, and whenever we find the character C equals to the character that we are iterating on top of, then, well, we add 1 to our result. So let's create a variable called result, which will contain 0 initially, and then I'm gonna loop through the entire string. So for I starts from 0, I is less than len I++. So that will allow us to iterate through the entire string. And then if the character at index I is equals to the character C, in that scenario we're gonna increment results. So result ++. Okay? Now after we complete this for loop, then we have our result variable containing the number of occurrences of the character C inside the string, inside the string, the str string. Now let's return that result. Okay? Now we've created a function that does a job. So now, according to the Pandora's box theory, we're gonna have to forget about that function, how it works. Okay? It just does job magically. We don't have to think how it works anymore. It just works. Okay, let's test. Of course, we're gonna have to test that it works before assuming that it works. So let's test whether it works or not. So I'm gonna printf d, a number, an integer, and then I'm gonna compute occurrences, and then I'm gonna give that the character space, for example, and then I'm gonna give it also the text variable, the text array, the text string. And let's see whether it works or not. Well, let's so here there's a missing semicolon there. And as you can see, it says 14. And if we get back to the problem statement, we have 14 spaces there, so that works. Okay, so our function works, so we don't have to think about it anymore. We just need to use it. It is tested and it works. Now, since we do know how to compute the number of occurrences for any given character inside any given string, what if we loop through the all of the characters, and then for every character we see how many occurrences do we have for that character. So let's do that. So for I equals 0, I is less than len, I plus plus. So that will allow us to iterate through all of the characters. And we're going to declare a variable c, which is going to be text of I, the character unindex I, and then we're going to call the compute function. Now the compute occurrences will take the character, the target character, and will take the text string, and will return how many occurrences. So let's print that, okay? Or let's store that inside a variable called ox, for example, which stands for occurrences. Now if the occurrences we have is 0, which cannot be 0 because we're iterating through the characters of the string. So if it's 0, then do not print anything, otherwise print. So if ox is 0, or let's say if it's not 0, then print. If it's not 0, if it's bigger than 0, then print. So printf the percentage c, that will print the character c itself, and then colon, and then space, and then %d, which will print the number of occurrences. And then I'm gonna print that symbol there, that separator. And then I'm gonna print the character c. I'm gonna give it the character c as the first argument. And then for the next argument, it's going to be the result ox. Now this should work. So let's try that. Now it prints something, but let's see whether it is printing true or not. So well, basically it says c is 3, space is 14, L is 8. Let's see whether that's the case or not. So here we have, yeah, well, it works, right? So it works. So here we have the C, we have 3 C's, we have 14 spaces, we have 8 L's, so L, we have 8 L's, we have 8 A's, so there you go, 8 A's, 3 N's, and so on. So it works. But it is printing a lot of output here because there are repeating characters. Okay, so for example, here we have spaces here, and we have space here, and we have space here, and we have space here, and so on. So we have to remove that redundancy from there. And the easiest solution for this problem is to mark every character whether we've already seen that before or not. So let's create, well, let's create a Boolean array, and I'm gonna call this Boolean array seen, okay? Whether we've seen this before or not. So this Boolean array will be of size, well, let's give it a size, let's give it a size 100, okay? Or let's give it a size 256, because we have 256 characters, different characters, okay? And then we're going to initialize this array with false. So for I equals 0, I is less than 256, I plus plus, scene always takes false initially. So scene of I takes false. So that will initialize the scene array to false. So we have not seen any character for now. And here, whatever we take a character from text here, here's what we have to do. We have to check whether we've seen this before or not. Okay? So if we saw the character C before, If that's true, so if that's true, we saw it before, then we have to jump to the next iteration. So we're gonna call the continue instruction. Okay? Otherwise, we're gonna mark this as seen. So seen of C takes true. So if we've seen this before, we move to the next iteration, we discard the rest of the instructions here. Otherwise, we execute the rest of the instructions, and of course we must label that character as seen. Now if we execute this, as you can see, there's no redundancies anymore. Now let's get back and the same answer, the same result here. So we have C3, we have 14 spaces, we have 8 A's, and so on. Now this is method 1, okay? So this is the first approach to solve this problem.